Okay, on to lightning. And remember that the National Weather Service will not issue a warning if there's lightning out there. That, in fact, we all know that lightning can kill us, but they will not issue a warning for lightning associated with a thunderstorm system, because they're hoping we'll be safe with regard to lightning. I have some safety tips later on making sure we're hopefully take precautions with regard to lightning. But I want to start out with the two types of lightning. And this isn't like ball lightning or heat lightning, but this is like where the lightning goes, what objects the lightning goes between. So the things that both of these lightnings have in common is basically it's a flow of electrons trying to get from one region that has a bunch of electrons to another region that is deficient in electrons. So we have this thing called cloud-to-cloud lightning, and it is also known as sheet lightning. And notice that of the two types, it makes up far the majority. 80% of lightning happens between clouds. It'll happen within the same cloud, a region of negativeness and a region of positiveness, and they have electrons flow, or it can happen between two different clouds. So this is, again, what we call sheet lightning, and I know you've seen this. It's kind of vivid and it makes me smile to kind of think of this sheet lightning. So the whole sky kind of lights up. The other type of lightning is the lightning that we need to be, the lightning that can harm us. We need to be concerned about both types of lightning. If there is cloud-to-cloud lightning or sheet lightning, there's definitely the potential for cloud-to-ground lightning, but only 20% is cloud-to-ground. And so what happens, and I'm going to kind of talk you through it, but I won't spend a lot of time because it's not entirely understood, but basically what happens is we'll have a negative charge will be created at the base of the cloud, and then what will happen on the Earth is that, and the Earth is one big store, it's a great grounder, so which means that the Earth can provide electrons or it can absorb electrons. So what happens on the Earth, how it responds is, for this sort of lightning form, is a part of the Earth will have a basic positive section. This is kind of what I'm drawing here. This is my base of the cloud, and we'll talk more about this here in a minute. Okay, so within the cloud I'm going to go ahead and make little negative signs here. And we'll talk about this in a minute, but within the cloud, we also have positives up there. And for cloud to ground lightning to occur, this is the Earth's surface. I'll go ahead and draw a tower or a tree. So what will happen is in that top of that thing will be induced what we call a positive charge. And the reason this positive charge is created is because of the presence of this negative charge. And so we're setting ourselves up for that 20% of lightning that is cloud to ground. So I'm going to kind of talk you through I think I have 6 different pictures to kind of show you how lightning kind of progresses. But remember, lightning is the visual part, and the reason you're seeing it is you're seeing the heat that's created basically and gives us light that we can see, and the heat is created as electrons move. So kind of starting out, first off, I believe when we talked about hail, we talked about this cute little, well, it's not really cute, it's kind of ugly little chunk of solid ice that can be within a cumulonimbus cloud called a grapple. So the grapples are different than our ice crystals. Our ice crystals are lighter and our grapples are heavier. And if you kind of think of, if you take a balloon and kind of rub it on your head and you kind of build up some sort of static electrical charge between then your hair and the balloon, you're transferring electrons, and it's sort of this sort of friction between these lighter ice crystals and these heavier grapple crystals that they basically, between those two particles, the grapples end up with their fair share of electrons. So they're negative down here, and the ice crystals have lost electrons, so they're positive up here. And because ice crystals are lighter, they rise. So this is how we get our charge separation within our cumulonimbus cloud, our vertical charge separation. So I don't know if you can see it, but also on this slide, like I showed a minute ago, we kind of see the beginning or an induction of a positiveness. There's little positive charges down here at the Earth's surface. So we're getting ready for the 20% of lightning that is, where's my thing? That is cloud. This is my lightning bolt, cloud to ground. Okay. Now, these terms, leader and step leader, I'll just go ahead and tell you, I think there's a test question this semester, spring 2012 anyway, of that basically I'm not going to ask you to walk me through the stages of the formation of lightning, but I'm going to ask that you recognize, for instance, that the terms leader and step leader are associated with lightning. Okay, so what happens then is that the region of space that is ultimately going to carry the charge of the electrons becomes what we call ionized. First, and so we have an initial flow of electrons called the leader. First the leader, I think, and then the step leader. And kind of what's associated with this process, again, it's not entirely understood, but it is what we call a runaway breakdown, and it's kind of basically takes on a life of its own as those electrons begin to pass from the cloud, the region of negativeness, to the ground, region of positiveness. I don't know if you heard that, but so the lightning flash, actually, can you see by this time exposed photograph that actually there's kind of in the vicinity of each other multiple lanes of lightning. And so a flash actually is electrons kind of going back and forth between, if it's cloud to ground, between the cloud and the ground along the same path. And you might have even seen this before. Sometimes don't you see kind of a ghost of an image of a lightning bolt, and then you see the real thing? So actually what we call lightning flash oftentimes is going back and forth several times. So I think, again, on that same one multiple choice test question, I want you to recognize flash and maybe even strokes are terms associated with lightning. Okay, this is just kind of return stroke, again, is kind of the back and forth sort of flow of electrons between the region of negativeness and positiveness. Now, part of the reason we kind of have a back and forth sort of thing is kind of it, as electrons flow, they kind of, where it was negative, they create a positive region, where it was positive, it created a negative region. So it's kind of an overcompensation sort of thing. Dart leaders are also associated with the flow of electrons, kind of follow up. These would all go part of what we call the flash of the lightning. Hope you're getting all these words. If you're filling in your slides, let me know if you need me to send them to you. But again, I just kind of want the overall look at the process of lightning. Remember, when we talk about lightning, we're talking about that visual portion. Okay, and I have it here when I talk about thunder, but actually lightning, the reason we see it, like I said a minute ago, is this flow of electrons we've been talking about actually heat up that region where the electrons are flowing, and then that emits energy and light that we see. So here are the 6 slides kind of from left to right, talking you through the process of that special 20% of lightning is cloud to ground that we call lightning. So again, just let me know if you need help filling in any of those words.